Okay. Anthony Priscilla, we're doing some linear programming in Math 1324 today. This is actually an introduction to linear programming. We're doing this with the graphical method. And we've said that if we have a closed and bounded feasible region, then there's both a maximum and a minimum value. So here on this one, what would y'all say this is? Is this closed and bounded or unbounded? If it's unbounded, there's only one, then there's only one, either a maximum or a minimum, but not both. So what would y'all say this feasible region looks like? Closed and bounded? Yeah, this is a closed and bounded feasible region. Ooh-wee. I need to use darker pen. It'll look really good on the video. This brightness is only affected by that projector there. It doesn't affect by the finished product there. So we're looking at the corner points, and on here you can sort of look at them and figure out what they are, but they tell them to you right here. Here are the corner points. Since this is closed and bounded, there's definitely a maximum and definitely a minimum. And it's going to occur, they are going to occur at these corner points. So I'm going to make a little table. It's going to look like this. I'm going to write the 4 corner points. And the corner points are 1, 1, 5, 9, 8, 8, and 9, 5. And we're given some function, 6x plus 2y. And we're going to try to figure out what's the minimum value of that function over this region and what's the maximum value. This is actually a huge statement. If you can you imagine all the millions and millions of little points that are in this blue region? If you were to take ordered pairs from this region, from now, let's say you do it all day, pluck an ordered pair, put it in here. What's the smallest number you would get, and what's the largest number you would get? Well, since it's closed and bounded, there's going to be a smallest and a largest number. And it occurs at they occur at these corner points. So let's see, plugging in a 1 and a 1. You're plugging in x and y. So what's that going to give? 8. Now plug a 5, 9. 6 times 5 plus 2 times 9, 48. Now let's plug an 8, 8 in. That would be a 48 plus 16, 64. Then plug in a 9 and a 5 in. Plug a 9 in for x, a 5 in for y. Is that going to be another 64? Oh, okay, 64. Because this graph is closed and bounded, because the feasible region, the smallest number here, that's going to be the minimum value, 8. Ooh, you see that blue? Now, the biggest number here occurs twice, but it's still the maximum value. So to fill in these blanks here, the maximum value is 64. You put a 64 in there. And it occurs twice at the ordered pair 8, 8 and the ordered pair 9, 5. The smallest y value here is 8, and it occurs at the point 1, 1. Now this is actually very, very significant. Given these constraints right here, would it be possible to get a 65 here? No. Imagine all the ordered pairs. Can y'all imagine that there's a lot of dots in here? All the ordered pairs in this shaded region. If you took them and plugged them in, you'll never get a number bigger than 64. What about a number smaller than 8? given these constraints, could you ever get this function here, 6x plus 2y, to equal 7? No. The smallest it'll ever be is 8. The biggest it'll ever be is 64. Okay? And we're going to see some nice applications of this before it's all over. Any questions there? Let's do number 3. Students will usually like number 3 because the ones where the graphs are given to you, on number 3 they give you the graph, but wait a minute, they sort of like it until they look really closely. On number 1 it gave us the corner point, same thing on number 2. That's why I'm skipping number 2. Number 2 is just like number 1. But here, it doesn't really write out the corner points are. Okay? So, how do we want to, what are we going to have to do? Well, if we look really closely, the red region is the feasible region. Could y'all come up with one corner point? 0, 0. Okay, there's one corner point. Ooh, and if you look really close, I don't know if y'all can tell that. This is not at 4, is it? And this one right here, is it at 6? It looks like a 6 to me. Over 0 up 6. Well, how do we figure out this corner point and that one? Well, let's go through and graph it the way we were graphing the linear inequalities up here on the board. I'm going to take this first inequality, 6x plus 8y is less than or equal to 48, and make my little xy table. We're going to plug 0 in for x, figure out y, plug 0 in for y, figure out x. So what are we getting here? If I put a 0 in for x, is that going to be a 6? If I plug a 0 in for y, what are we getting for x? 8. So, okay, those are the 2 points you could sort of tell. The 8, 0, is it a corner point?
Yeah.
Well, it's down here, but corner points occur.
Why not a corner?
Yeah, it's only the shaded region here. So it's a point. It's an intercept, but it's not a corner point. So far 0, 6. We still have this corner point here. Okay. And that one there. If I take that second equation, inequality, 13x plus y less than or equal to 48. Plug a 0 in for x, figure out y, and then plug a 0 in for y, figure out x. Let's see, what are we getting? This first one, when we put a 0 in for x, is y going to be pretty big or small?
Big.
It's pretty big. It's what, a 48? Is that point showing on the graph, the over 0 up 48? No, you see that's why here it just keeps going and way off the screen it'll hit the 48. Plugging a 0 in for y, what are we getting?
3.43 something.
Okay, so if I plug a 0 in for y, I have 13x equals 48. Divide both sides by 13. 13 doesn't divide evenly into 48, does it?
So x equals 48.
So I'm just going to write it as 48 over 13. Which one of these 2 points is a corner point?
The second one?
Yeah, that 48 over 13, comma 0. Okay. We still need to know one more corner point. Well, Jenny and Deborah have calculators that would find that other corner point really easily for us. Well, what are we going to have to do to get this other corner point? Well, have we solved equations have we solved something like this? 6x plus 8y equals 48, and 13x plus y equals 48. What method, which homework assignment did we solve stuff like this? We used our matrix, Gauss-Jordan elimination, that solves system of equations. So you could use your calculator with Gauss-Jordan elimination, or way before Gauss-Jordan elimination. If you think back to way in a previous algebra class, you would have done something called elimination or substitution to solve this. Y'all remember that? If I have 6x plus 8y equals 48. Now, Jenny, if you or Deborah have your little calculator that solves these simultaneous systems so nicely, you can punch it in and be done with it. Well, if you want to stick it into your matrices, if you have a TI 83 or 84 or something like that and want to put it in as a matrix, then and get the answer, that's fine. I'm going to do this elimination. I prefer elimination rather than substitution. With elimination, you add the equations vertically in such a way that one of the variables subtracts out. Like right here, where this y is, if there were a -8, then when I add vertically, they would subtract out. So if I multiply this second equation by -8, 13 times -8, that would be a -104x minus 8y. Now what's 48 times -8? Let's see, I don't even know if I have a calculator up here. 48. 84, so a -384. What I'm doing here is called elimination. You've done it somewhere along your life, okay? If you don't like doing this, then this is a good excuse for you to get out your calculator and do a Gauss-Jordan, enter the matrices and get it in reduced row echelon form. And when we add vertically, notice how the y's subtract out. So we have 6 minus 104. That's going to be a negative what? 98x equals 48 minus 384. That's a negative 48 minus 384. Negative 336. Divide both sides by -8. Excuse me, negative 98. Does 98 divide into 336? I don't think so, does it? So, I wish I were using my other little calculator. It would reduce the fraction. Let's see, how could I reduce this? 336, oh, I know how. 336 over 98. Wait, it's a 42. No, it couldn't. 336 divided by, oh, I said 48. I meant 98. 336 over 98. That would reduce to 24 over 7. Okay. So, Jenny, what does yours do? Does it give decimals or fractions? Or did you not? Oh, okay.
This is what, I entered the first one,
Uh-huh.
and then that's what it gave me.
Okay, so it's writing it as a decimal, 8.4285.
And then it says 24/7 right there.
Oh, 24%. Oh, yeah, really nice. Jenny has a Casio FX 9750 G2, and using the equation feature and simultaneous, it sure does solve this stuff nice. Now, so that's giving you the X value, 24/7, and scanning down, let's see, how do you get that Y, if I say that, let me see, solve again. How do I get it to give that Y value as a fraction? That's what I'm wondering about on there. But oh yeah, that's a nice one. So here's X, 24/7. So what's Y? Well, I'm going to plug 24/7 into one of these equations and solve for Y. I'm thinking it might be easier to plug it into the 13x plus y equals 48. So I'd have 13x plus y is 48. So I'm plugging 24/7 in for x. So I'd have 13 times 24/7 plus y is 48. So 13 times 24 is 312. Oops, that's over 7. 312/7. So subtract. So we'd have 48. Ooh, I'm out of room. Let me move it up. 48 minus 312/7. So if I go 48 minus 312/7, 48 minus 312/7. It's another 24/7. Does that look right?
Yeah, it gives me when it gives me that XY, it's the exact same definition.
Yeah, that's why when I moved the arrow down, I was like, why didn't it change that? I couldn't see the smaller numbers on the matrices for yours, but they're the same thing, aren't they? Okay. Wow. So we have this corner point, 24/7, comma, 24/7. So where are we at this point in the problem? Well, we're at basically where we started with problem number 1. On problem number 1, they gave you the corner points. So at this point, all we've done is found the corner points. So we now write a new table. The 4 corner points are, I'm going to do the little corner point table. 0, 0. Now what was this point here? Oh, 48/13, comma 0, 0, 6. And then that other point, 24/7, comma 24/7. And only one of these I can plug in real easily.
You lower it down.
Oh, there. So I have the corner points there. So the 4 corner points in the 24/7, comma 24/7. That was the one that we just found with elimination. Or if you want to plug into your calculator and use however your calculator solves it, either with matrices or simultaneous equations if you have one of those Casio calculators. So now we're going to plug these corner points in. 0, 0, 9 times 0 plus 10 times 0, that's just 0. 48/13, comma 0. Hey, maybe we can do that one without too much trouble. In our head, if we put well, you know what, I'm not going to do it in my head. I'm going to write it out like this. Plugging a 48/13 in for x. Oh, my brother gets so annoyed when he sees the page turned. And he has this little science behind making a mark on the table and lining it up so that it's never crooked. And I tell him, no, I'm not going to do that. Okay? So let's see, 13 goes into 39 3 times. 3 times 48. What's that going to be? Is that a 1? Huh? I heard someone say it. 144, okay. Now plug in a 0, 6 in, I can do that in my head, okay. Now the next one, the 39 times 24 over 7 plus 10 times 24 over 7.
168.
7. 168, oh, okay. So I think we're finally ready. Hey, it doesn't ask for both of them, does it? The question says, what's the maximum value and it occurs at what point? Okay, so the maximum was 168 and it occurred at that ordered pair that took so long to find. The 24 over 7, comma, 24 over 7. Okay. Any questions there? Oh, we're out of time. So we'll pick up doing more of this stuff on Thursday. And at that point, I'm going to show you all a website that will help you get through some of the messier stuff. Okay? So I'll see you on Thursday.